and we can briefly start this session. We are going to look at multi-tier database architecture as well as the business rules which are associated with database implementation. Actually, have you heard about multi-tier architectures? Especially in web you see multi-level architectures. Do you have any idea about such kind of thing? Before we move into database related multi-tier architecture, so we can come up with some idea which you are familiar with, then we can discuss and try to understand the concept of having this multi-tier database architecture. Have you seen any tiers, different tiers in your web designs, or especially in web you see this multi-layered architectures? What is your idea?
Sorry, is it like client and server architecture?
It is one of the basic level of architecture, having the client and database in two different ends. So normally we call that thick client architecture. In that, multi-layered architecture. In the same way, we have different layered architectures for databases. So if you talk about the brief history, in the early days we had only desktop applications. So today we have more than desktop applications like web applications, and you have separate mobile applications and other many levels of mobile applications also available. So we have to cater for such requirements. Then it is anyhow depends on what is we call as client server applications. In that case, database is running in the separate layer. It can be in the same network or in another network when we divide it into several layers. So the clients with the clients in the network can access the database. Depending on the privileges, they are able to read or read and write both is possible. In desktop applications, your application directly communicate with the database. Right? Have you learned about the difficulties of having such architecture or such implementation? Let me ask one question. Have you done any programming part, like designing an interface and binding that to a database in your whatever, in your programming subjects? Have you done something like that, designing an interface, then you can bind it with database access or whatever database?
Yes, with local server.
Right. Then did you know any difficulties of doing that? Actually, when you were doing that module, have you ever discussed with the inherent difficulties or issues with such design?
No, sir.
Right. So when We will talk them in other slides. So for the moment, so you have to keep in mind the application directly communicate with the database engine. Right? It can be whether local or remote database. In different ways, you may have different ways of connecting to a database. It can be OLDB connection or whatever provided by the particular language. So you can use that connection. And the other thing, what we call the business logic is hard coded to the application. For the moment, you just keep in mind in such a way that we will be learning when we discuss about the different layers in the multi-layered architecture. Then we first look at the two-tier client-server architecture. As you already told me, you have heard the client and server having two-tier client architecture which we call client-server architecture. There are many architectural designs. Actually, we call them as N-tier architecture. N can be any number of layers. But in practical, we cannot implement any number of architectures. For the moment, we have n equals 2 and n equals 3. So we got three-tier client server architecture. If you find any other sub-levels, then you can name it as 5-tier or 6-tier, whatever the levels. But for the moment, the implementation caters for three-tier client server architecture. Therefore, we have main two types of multi-layered architectures. The first one is two-tier client server architecture. Here, the two tiers are the client tier as well as the server tier. In your case, the presentation layer, that is the visual components, comes to the client tier. That is why I asked you whether you have implemented a graphical user interface and bind it with the database. So if you have done that thing, then your client part is the GUI part. Then have you ever written some SQL stuff in the client part, then GUI part? When you do such implementations, your user interface, did it contain any SQL related stuff? Can you remember? If not, how did you communicate with the database? For an example, if you want to save some data in the database through a graphical user interface, then your form should let the user to type some information, and once you press the OK or submit button, then it should be sent to the database and it is being stored. So how did you do that thing? Actually, using what language you did such kind of programming in previous semesters? Right. Anyhow, if you are not familiar with what I discussed, I think you may not remember what you have done. Normally, if you use C#.NET, then you might have written some SQL statements within the client side, and you execute once you click on a button, the SQL being executed, and it is sent to the database. Anyhow, there are some advantages of having two-tier client-server architecture. Therefore, we still use in some applications. As you have done, it's very simple. That is why you also have done such kind of implementations. You can easily develop applications due to simplicity. So you can gain the maximum user satisfaction and fast and accurate prototyping of application. You can use many robust tools available to connect and communicate with the database. The other important thing is it contains static business rules. So when we discuss about the business rules, you will get to know what are the business rules and what is the importance of that. For the moment, you just keep there's something called business rules. The static means the business rules are not frequently changing. Therefore, this type of architecture is more applicable for homogeneous environments. And the other thing is, database and business logic is physically close together. Therefore, it can offer higher performance compared to other N-level architectures, entire architectures. Apart from the advantages, there are some disadvantages as well. As I told you, if the business rules are rapidly changing, right? If it is not static and rapidly changing, then this type of architecture is not suitable, because you will always have to change your hard-coded programming level stuff to represent the new business logic, right? For an example, now let's say in your form application in C# or whatever languages, if it is hard-coded to your interface, then you have to manually change all the interfaces to represent the newly introduced business rule or the logic. Okay? It's obvious, if it is hard-coded there, it is very difficult for you to change only the interface, because your database component is also hard-coded there, right? It is not giving much flexibility. Now, if you take a supermarket system, they are frequently giving you different types of various offers, right? It's very competitive. In such environments, you may introduce different business level, which we call business rules, depending on the period. For an example, now the New Year season is almost coming. Therefore, they are going to introduce various types of offers. Right? In that case, you may need to change the system frequently, right? But do you see any difference when you go to point of sales, the cashier? At the cashier, they always do their job in the same way. They just want to swap the barcode reader, swap against the barcode reader, and it reads the relevant details, and system knows how to deal with that, right? So once the system changes, everything applies to the client end, right? It's very flexible. Otherwise, if the environment and these business rules is going to rapidly change, you would not be able to uh, change that system according to the requirement. If it is a centralized system, then all the overall island-wide outlets can be monitored and configured from a single point. That is very important. And the other disadvantage is, since the client behind the most application logic problems, and controlling the software version and redistribution of new versions is also difficult, right? Because if you do that thing, so once you install your new version, it would not compatible with the database end. Then you have to again change the database side. It's very time consuming in industry applications. Right? The other thing is, if you take the security, it's again complicated because it needs separate login information for every SQL server. Right? Therefore, handling the security is again a problem compared with the other multi-layered architectures. As we have already discussed about the expansion capability, the two-tier model is difficult to scale up to other levels because it limits to number of users, and simultaneous client requests is also lower compared to other entire client server architectures. Therefore, it has to be operated as a separate connection, and it needs CPU and memory to proceed with the request. It is poorly scalable compared to entire client server architecture. The other drawbacks are minimal logic sharing, since the logic is highly coupled with the client end. You cannot reuse the logic. Right? I think you might have an object-oriented programming, then you might be familiar with coupling and cohesive. Are you familiar with that? Coupling and cohesion? Have you heard about these two words?
We'll answer, but not much used in practically.
Right. In coupling, actually, what we do is, if one module is highly depending on another module, right? Now, in this case, the application logic is highly depending on the interface, because we have embedded our logic into interface level, right? So database is in separate layer to communicate and retrieve and store data using the database. We have to have some kind of logic associated with. That part is handled and embedded in the client end. Therefore, it is coupled. We call it highly depending on the user interface. Therefore, once you want to change the logic, then your interface would also change. And if you want to change the interface, then your logic would also change. The other thing is you cannot reuse the same components again and again. If you take one example, this comes under cohesion. When we talk about the coupling and cohesion, we call the lower the coupling is, the better. And when we talk about the cohesion, the higher the cohesion is, the better, right? Cohesion means the reusing of existing modules as much as possible, right? For an example, when you implement your programs, first you have to design and come up with a UML diagram. Then you identify different modules and their dependencies. Once you found the dependencies, you have to minimize them. If it is really needed, then there's no choice. You have to keep it as is. But you have to identify the module where you can highly reuse. If you take one example, you may write a print method or function to print a certain document. So then you can reuse that document to print many such documents, right? So you have to design in such a way. If you write only print method to print database, whatever the, let's say a certain report, then you may have to come up with many print methods to print different things, right? In such a manner, if you can reuse the same module again and again, if you have designed it in that manner, then what you have to do is you just have to call that function in your program, right? Otherwise, you have to come up with totally different functions for each and every operation, right? Therefore, it is very important to have high cohesion. But in this two-side client-server architecture, the reusing logic is very minimum. And this version of application is the other drawback. So, as I told you, any change in an application has to be changed in the client side. So, if the number of users exists in the system, it entails a substantial administrative overhead. Now, let's say you have only 5 machines connected to the database. I think it's already possible to maintain. Right? Now, you just take hundreds or thousands machines connected island-wide in a supermarket system. So, can you go to each and every individual computer and do the required changes, frequent changes overnight? It's not possible. It's not practically. Right? Therefore, when the number of users or clients are higher, then it becomes a substantial administrative overhead. If you use two-tier client-server architecture. Then the other drawback, when you want to change the database structure, your database and client are hardly bound together, then you have to redesign the interface level structure as well. Then it is very difficult for you to change only the database, right? Because the logic of accessing the database is built in the client side, so you need to change the client side as well. If you change the database table structure, then you should definitely change the client side as well. Otherwise, you will end up with errors. That is why I asked you whether you are familiar with doing such simple programming using a small GUI created by C#.net or whatever you are familiar, and connecting it to a database. If you have done this thing, you might have changed either client side or database side. Then you can see the problems encountered. Anyhow, there are typical applications of two-tier client-server architecture. When we have normally around 10 to 100, it's not hard and fast, but it depends on the actually decisions made by the expertise. Therefore, we can normally go for this type of arrangement. So, small company organization, you can go for typical client-server, two-tier client-server architecture, right? Because they are not going to frequently change the requirements, and with that two-tier client-server architecture, you can have both installed in average level performance machine, and you can continue. But in extremely larger companies, you may not be able to use this type of thing because number of users and concurrent access and many more related to performance as well as the business logic is requiring higher capacity. I think you may familiar with this type of databases and webs, and with that you can think how complicated this type of real world application. So with that, these applications are intensively used by the web applications. So if you look at the familiar and popular websites like Amazon, eBay, or they are entirely database driven application. What you see is actually depend on the how they have configured. You may not be seeing the same interface again and again depending on their configuration. Actually, your interface would also be customized locally or regional levels. Right? For an example, the interface you see from Sri Lanka may not be the exactly what you see in America or UK, whatever the other countries. They are highly customized, and the central system can be configured to cater such requirements. To do that, we have to go to multi-tier architecture. Right? Now, first you have to keep the things we learned in two-tier architecture, then how this multi-tier architecture is different from the two-tier. Again, in multi-tier architecture, we go for 3 levels. So we learned that in theory, we can have many tiers or many levels in proposed multi-tier architecture. In this case, the most common is the 3-tier client-server architecture, where you have another layer implemented in between client and the database server. We call it a middle tier. We will look at that in a pictorial manner. So you have client end and database end. So in between, you have another layer called middle tier. So it can configure, and it is the third party in between communicating with the client end and database end. You can briefly first go through this slide, and then we can discuss. And when you go through the slide, keep the facts we discussed in previous slides regarding the two-tier client-server architecture. If you take the presentation layer, as we have discussed in two-tier client-server architecture as well, it can be a web browser, or in Java you can use an applet, or it can be wireless application protocol related phone or whatever mobile device running the web protocol. And if you take the business layer, the things like data validation, insertions, calculations, such things can be put into business layer. And the data access layer is responsible for databases, or it can be mainframe system or ERP system. In between data access layer and presentation layer, the business layer is placed. Therefore, those two layers are separated and interconnected using the business layer. With that, we can implement better reusability, data integrity, and scalability, as well as the performance with the higher end environments like multiple concurrent accesses and having many business rules being frequently changed. Such environments, it is giving much performance compared to two-tier client-server architecture. Right, this is the pictorial representation of what we discussed. You can carefully go through the diagram and identify. The important thing, if you have done your practicals in previous semesters, you can recall your memory and try to map what you have done with these diagrams. Then you will be able to understand. Have you used any application servers in your previous semesters to implement web-related? Can't you remember, have you ever used something like Apache Tomcat or Apache Triad, whatever the normally small level application server?
Use Apache.
Apache is So have you configured that? I think you might not have had the idea about application server and business logic, whatever the thing, but you might have done such thing,
Yes, sir.
right? It is one way of doing this thing. Now, if you take two-tier client server architecture, you might have just design an interface and directly bind it into the database. But in these type of applications, you are creating the interface and there's configurations in the application server level, and then after you have the database separately. So when the client clicks on certain buttons or certain things on the client end, application server gets a request and send that request to the database end and get the response and present to the client end again. Right? So that type of thing is happening in the applications. If you call the client in three-tier client server architecture, the application is trimmed down. That is compared to the two-tier client server architecture, the application, the load of application is minimized from the client end. Right? That load has been taken out from the client end and it is put in the middle layer. So we call it as thin client. Thin means that it is lightweight. Now the client is lightweight. In the two-tier client server architecture, client is called thick because the load for the client is higher compared to multi-tier client server architecture. With that, the client tier can provide many state-of-the-art rich user interfaces to the user, more attractive and convenient user interfaces for the users. And it communicates to the database layer only via the middle or business tier. Right? There's no direct communication. Therefore, you can change your interface and without changing the database. Right? If you totally need to change all the system, then you might rearrange the database structure as well. But just to, for the sake of changing the interface, you should not require to change the database level. If you take the middle tier, in general, middle tier performs two major tasks. One thing is isolating the client application from direct access to the backend, that is a database. And the other thing is it coordinates and merge the enforcement of business logic and business rules, which we'll be learning after some time. It is the controlling players or the governing players of such business rules. Therefore, you can maintain one central place for business rules to be enforced. Therefore, as a system administrator, he can change the business rules in a single point, and it will be reflected in all the client applications and the client end. Therefore, full control over the data access belongs to this middle tier, and it is most probably deployed in a very secure location. If you discuss about the disaster management and business continuity plan, then it has to be also taken care of. These database systems are secure because it is containing the most important data. Actually, when we talk about the databases, there's many more other than SQL, ER diagrams, and other technical things, because you have to sometimes think of very small things, but it accounts for very higher importance. Now, if you think of a database server, the failure of a database server can ruin a business, right? Therefore, the physical and logical security, where when you talk about the logical security, you can think of intruders, attacks for a database. And if you think of physical problems, the database server, the location has to be secured. Sometimes it could be flooded, and then your whole database server becomes unusable. Then what happens? Then you may need to go for backup servers, and you may need to decentralize your database architecture, the physical architecture. And there are many things to be considered when you actually implement a database. Right? At your level, I think you are familiar only with SQL thing. So you may feel knowing only the SQL and ER diagram would be sufficient to implement a proper secure database system. But you may also have to be aware of other factors like cost associated with database system. If you are really working in the industry, then these factors matters a lot. Right? Now, if you think why should a company goes for MySQL and why should another company go for Microsoft SQL, and another company would go for Oracle system, spending billions of dollars and upgrading their system to that level. So there are reasons. Therefore, you have to always think in different ways other than just SQL and ER diagrams. So that is only for logical database design and implementations. But when you talk about the physical things, there are a lot more has to be considered. When you think of a job role of database administrator, and he has to take care of many things related to database. So when the time comes, we will be discussing important things. And if you take the data integrity, and it is also ensured at the middle tier of the three-tier client server architecture. Then we go to database tier. as you know, at the database tier, what you do is we store all our required data securely, and it has to be well protected against any unauthorized access. Therefore, in databases, you have access levels to be maintained. In your course modules, you might not still have learned about how we protect a database. It is again very important in the context of database implementation. Right? It is not just writing some SQL stuff. There has to be many things considered. In that case, we need to have well-protected database system against the unauthorized accesses. And the other thing is user level restrictions. As I told you, you can configure depending on different database management systems. They give you different ways of configuring. So with that, you have to design and identify what to be done using that access levels and how it has to be configured. Okay. It is again very important thing. Create a database type. And if you talk about the advantages of multi-tier architecture as opposed to two-tier client-server architecture, the scalability is improved. Right? Actually, it is due to the distributed nature of application server and database server in another place, and middle tier you can decentralize your database server, application server in separate locations, and you can scale up to many users, and you can come up with proper load balancing systems. If you come up with the different database servers, you can balance the load to different database servers. If you have backup copies, then you can get more advantages. In two-tier client-server architecture, it is very difficult for you to have different database backup servers, because you always have to bind your logic into the database. So you cannot bind your logic with two different databases. So you have to always stick to one database when you do the two-tier client-server architecture in your database applications. And the other thing, as we discussed in two-tier client-server architecture as well, in that case, it is very difficult to reuse, but in this case, you can reuse the same logic to many client and other applications. So I have given some object standards like COM, DCOM, and COBA. You can just search in the internet and find some associate knowledge, and you can come up with a transparent business logic where you can easily configure client side as well as the database side using the middle tier. So it promotes the reuse of existing logic. Then the other advantage is improved data integrity. So when the client side is giving some corrupted data, it can be eliminated and data passed in the middle tier for database updations, and it can ensure its validity. So you can check the validity at the middle tier, and you can prevent from sending incomplete or partial or corrupted data into the database. To do that in two-tier client-server architecture, you have to manually handle the same thing in interface level. It is very difficult, right? Then you have to always change the interface and do the coding related activities at client level. All the time you want to assure the integrity, and any change is required. And the other thing is the security is enhanced with the several layer implementation. So you can improve the security, and it can be enhanced because the client do not directly interact with the database, right? Therefore, client cannot directly access database. Then it provides much security, and if you take the risk of configuration with unauthorized data, it is also minimized using multi-tier architecture. It can be further improved by having the business logic in centralized server. With that, we can implement more secure features than the two-tier client-server architecture. Then the reduced distribution. As I have already discussed about the scenario of a supermarket, since it is having the layered architecture, you can easily update only the application server, not all the distributed clients, when you want to do a modification in the business logic. And it's a typical scenario when you want to introduce new offers. Not only the offers, there can be many reasons. I am giving you a typical example where you can understand. When it requires to do certain business logic alterations, they can only change it at the central location, and it is displayed, or it is applied to all the other client levels in the system. Then other very important thing I mentioned previously, not only the SQL, but there are many things to be considered, like disaster situations and business continuity when we implement a database. In such a scenario, if you take a disaster situation, you may definitely want your organization to continue. Therefore, we should have something called business continuity plan, right? But if you have only one server available in the organization, then there's nothing to be done when it fails, right? if that particular the centralized database is failing, then you can't do anything, right? So if you take the risk of having such architecture is very high. Now, let's say your banking system, as an example, it may fail. Then what happens to the clients who are accessing the database? Now, let's say you are at that time, the many people may be doing their transactions. They may be paying their bills over the internet. Some may be accessing the banking system through an ATM. There may be many situations and many scenarios. But if the banking system fails, nobody is able to access the system because the database is no more available. Therefore, we can go for distributed databases having redundant data, right? You can have an exactly the same copy in another location, or it depends on the way we implement, right? For the moment, you just keep in mind, you can have redundant server. If you check the redundant, then you get the main idea. You can have only if you have only one server, then you have to identify what the risk. Then you can go for many other servers which we can run as a backup. When one database fails, you can start up and connect your clients to other database available. Then your clients can still continue. They actually even do not know what happened regarding the database layer. It is hidden to the client, and smoothly the business is going on. Right? We have to have redundant servers. So if you take the banking systems or the mission critical applications, therefore, you cannot have any single point of failure in theory, right? If you fail anytime, you cannot estimate the issues and disastrous situation you face. Right? Therefore, the multi-tier architecture allows you to maintain redundant servers, and you can recover the system from network or server failures. It has to be well planned at the very beginning of data implementation. Right. Then there's another important thing. As I told you, with multi-tier architecture, the database is not directly accessed by the client side, right? Therefore, you cannot, as a client, you cannot know how the database tables is arranged, right? If you do not know how they are arranged, actually you cannot directly harm the database, right? It's very obvious. For an example, if a thief comes to your home, and if he is not aware how the everything is arranged, so it will be very difficult for him to rob the things at your home. Normally, they have the standard way of arrangement in almost all the houses. Therefore, they know how to rob a house. But if it is totally different, then they would also be in trouble. Anyhow, in uh, related to multi-tier client server architecture, the database layer is hidden to the client side. Then nobody knows how it is happened and how it is actually structured, because that part is by the middle tier, right? Only we configure the middle tier and database tier, and actually database tier also does not know how the client tier is configured, right? With that, we can implement higher and security uh, features to the database where it is difficult for intruders to access and do the modification. If you compare the difference between two-tier and three-tier architecture, in two-tier architecture, it follows a client-server architecture, and it maintains a straight communication link between client and server, and it gives high performance uh, as there is no middle layer, but it limits to number of users and concurrent accesses, something like that. If it is higher, then the two-tier client server architecture is giving many problems. That is why we have to go for multi-tier client server architecture. So in that client end, it can be any device like mobile, desktop, or laptop, where all the data is stored in a database, and database is directly linked to the client end. Right. Now we are going to discuss about the business rules. Before that, I would like to know whether you have any questions or anything to discuss with what we were talking about. It's very important. I also want to get some inputs from you, because ultimately you have to understand students are feeling the database is SQL and ER diagrams and normalization. But apart from that, we have to understand the big scenario when we have to implement a database. The SQL, ER diagrams, and normalizations, the things you learn are only small units of the overall database implementation process. Okay? Therefore, you have to have a kind of broad view regarding how this is being implemented, and the associated parties, as well as how to secure a database, the physically and logically. Those are also very important when implementing a database. So before we go to business rules, any questions? And also, do you have any idea? First, we address the questions. If you have any questions, so you can ask now. If you do not have questions, so what is your idea or what we discussed? Is it clear to you what we discussed about the
Yes, sir.
database administration?
Yes, sir.
Then we will talk about the business rules. As I told you in my first slides of this today's presentation, there is something called business rules. But now we are going to look into the business rules in further detail. So before that, I would like to discuss about the things. As I already mentioned, the database implementation is not a simple task for enterprise level applications, right? That is why I told you, knowing only the SQLs and ER diagrams, it's not going to work here. Only that part is not going to work. Therefore, we have to first identify the requirements, right? Now, if you take the classical waterfall model of the software development life cycle, you first do the feasibility study, then requirement gathering and analysis, and design, implementation, testing, and finally you deliver and do the maintenance if it is required. Likewise, there are many steps. Now, if you do the database implementation also, you have to follow a similar way of uh, procedure, a systematic way. Otherwise, you will not be able to properly implement an industrial level database. Right? To recall and refresh your ideas and come up with your own ideas, I would like to give you one question. So you can just take this into your notes and briefly describe the steps when you follow implementing a database. Now, for the moment, you can assume the requirements are finalized, right? So you know the requirements, then you are going to do the rest of the steps, continue to come up with the proper implementation, right? So I'll give you several minutes. You can come up with a very strong answer. Then you can think of all the things which we discussed up to now and come up with the proper answer, because you have to have this mindset in order to uh, understand the underlying concepts, right? Right now, I'll give you several minutes so you can just complete and then we can discuss. Done with the question. To identify, then how you describe them. You can assume the database requirements are finalized, so it is easy for you to explain the rest of the steps.
Hello, sir.
Yes.
Your voice is not clear. What did you ask?
Uh,
The answer?
yeah, the answer, the steps, and how can you explain that in brief?
First phase is done. Requirement are finalized. No?
Yes.
Then we have to design conceptual diagram like ER diagram and plan the database. After that,
Right. Then first you have to when the requirements are finalized, so you can further analyze the requirement. With that requirements, you can come up to logical database design using ER diagrams, right? This is
yes,
what you, right. Then after what you do?
physical design.
Yeah, physical design is the actually the last part. So physically you implement the database. Before that, you have to do the normalization. With that, you reduce the redundant values. Right? You minimize the redundancies using normalization. Then come up with the final set of tables, okay, with ER diagrams. Then after you have to come up with logical schema. Then you implement the logical schema with a suitable database management system. Then you come up with final database implementation. Then final database. In doing that, you need to identify two things: the logical database as well as the physical database. Normally, due to the complexity and data volume, we talk these two in two different manner. Those two activities are done by two different personnel, normally in larger systems, the logical database designers as well as the physical database designers. We look at them in detail. So once you refine the set of user requirements, you have to identify the data and identify the relationships, identify the constraints on data, and you should have thorough and complete identification of or the understanding of the business rules. Actually, the business rules in this case plays a major role. It can change according to the requirements. So some are static business requirements, some are dynamic. As I told you, the supermarkets may offer you several promotions as well as they introduce different offers. Those are actually for a period of time, not for all the time, it's for a given period of time. That is normally example for a dynamic business rules. Then if you go to physical database designers, they are responsible for selection of indexes. That is very important. And partitioning, clustering, and selective materialization of data. They are the actually physical implementers. Then they have to tune up the database to minimize the to cater the higher performance requirements of the database, and we can measure the performance by the time to delay get a response to a query, right? Therefore, you have to come up with a proper design. I think you are familiar with the indexes. Have you heard about the indexes in previous semesters? Have you used or have you even heard of indexes? Right, then you should, have you ever used indexes in your day-to-day life? Now, if you look at your normal telephone directory or a text box, there is something called table of content. It's a typical example where you encounter indexes, right? Why actually we use indexes there? What is the reason to use index?
To identify.
Still, we can turn the pages of the book and identify where the relevant chapter is. We can still identify, but why we put them in an index?
To sort a specific code.
Actually, no, it is not the main reason. You can quickly access the relevant data by referring an index. Right? Let's say you want to turn to chapter 5 or a specific topic. You first skim through the index and find where it is located. Then you can directly turn that page and get the content. In the same way, in databases also we use indexes to select the data very fast, right? Otherwise, out of millions of records, how can you select uh, and authenticate a particular user? Right? Let's say, since your database is having only 100 or 200 data, you may be able to write a query like select all from students where the student registration number is, uh, you can give in a sample registration number. But let's say you have millions of records, then how long it would take to select that particular record in the database? It takes sometimes hours depending on the volume of the database. If you write that query, then if you have to wait half an hour, then how can you cater for multiple and concurrent users within a minimum time period? Therefore, we have to index, carefully select the fields and index them using indexes, and it has to be carefully designed. Otherwise, having many indexes also drop the performance. Therefore, we have to carefully do the indexing thing. Anyhow, without indexes, your performance is very low. That is why we want to maximize the performance of the entire database. To do that, we may use the indexing, partitioning, clustering, and selective materialization of data. Now you carefully go through the figure I have given in this slide. can go through the points and you can map that thing into the screenshot, the figure, and try to figure out what is happening in the scene. Now, what you identify this presentation slide, what is given in this? It's a snapshot of an attendance system or leave management system. So it is taking some decisions based on the rules defined in the system. For an example, at the first, it has noted a particular employee is absent, and second, it is saying that on full day annual leave, whatever, in a particular day, and it identifies the weekends as well as and departure early. Likewise, how this can be modeled in the database, that is the important thing. So it is a typical scenario where we can enforce the business rules. It depends on the requirement which we want to cater for. Now, if you take the system which I discussed, it can be considered as a bit of an intelligent system, but you may have manually entered data as well as automated decisions. Normally, we do not promote the users to manually enter data into a database. It is normally captured through devices, or we can access through a system, whatever application. The decisions are taken automatically by the system without any manual intervention. So it is a typical way of having a database business rule. Right now, you can figure out what type of a thing can be considered as a business rule. Normally, business rule is like a constraint. The duty of it is to intended to assert business structure or influence the behavior of your business. Right? Then the main characteristics of data as viewed by the organization's perspective. In reality, the business rule is anything that captures and implements business policies. As I told you in a supermarket example, you can enforce many business rules or policy to make decision or infer new data from existing data. If you look at from the business point of view, it is a directive intended to influence or guided behavior. Normally, the business rules are decisions taken by the authorized person. Therefore, depending on their business, they getting their decisions, and you can implement that decisions using a proper client-server architecture. Then after, the system behaves according to the enforced business rules. So when you talk about business rules, there are some documents where you can find these business rules. For example, marketing plans, pricing policies, as I told you, in supermarkets, and customer relation management practices, HR activities, and there can be government regulations as well, right? Can you give me one example how the government regulations influence the business rules? Do you have any idea? Very recently, we experienced such kind of thing. I think everybody should be aware of some general things. How can we see the government regulations? How accordingly, how we should implement or alter our business rules?
Register the business?
Actually, registering the business is not stored in the database. No, it is not directly related to our database management systems. In related to database management systems, we are talking about the business rules for how you alter your system for changing government regulations. So then it is implemented as a business rule. For such a thing, can you give an example?
Number of employees and their working hours.
Yes, normally it is a kind. It can be a typical example for static regulation. But if you take very frequent things like government announces through gazettes for controlled price for certain goods, essential goods, right? So if the essential goods are to be sold at a certain maximum retail price, it has to be modeled or implemented through the systems, right? So you can find many things in such a manner. Therefore, it's better you can have some general knowledge, because all these things we learn in IT, we should see the practical applications, right? The IT is not something just to learn and keep quiet aside. We should see these things in action. Therefore, you refresh with the state of the art technologies and things we can see as applications of IT. I think it's clear to you. So, with what you have actually discussed, you can come up with something like this. The sales commissions can be modeled as a business rule, and the number of employees and their permanent employees also will be entitled for certain leaves, and a system can be tuned up where the all executive officers' duty will be from Monday to Friday, 8:30 to 5. Like it can be different from organization to organization. These are typical business rules where you can encounter in our day-to-day life. Some are very frequently changing, some are not. For example, the permanent employee will be entitled for a set of leaves that is not frequently changing. But the commissions, the sales commissions and the promotions of goods and such things can be frequently or dynamically changing. Now in this case, I have given you one another example. I think it is much relevant for you. You can just go through and try to figure out what it is meant. I think it's clear to you. Normally, you can implement such a thing. So when we about gradings and you calculate your GPA and everything can be done by business rules. So I'll be giving you one exercise. You can identify a set of business rules for a fixed deposit of any bank you wish. So with your experience also, you can write the answer for this question. So quickly take this into your notebooks and try to answer. Then after we can discuss. And now we can discuss the answers. Things you identified as business rules regarding a fixed deposit. It's a very general thing. Anyhow, it has to be modeled as a rule or constraint in the banking system.
Deposit insurance.
Deposit insurance.
Yes, sir.
What do you mean by insurance? Normally, deposit amount is one thing, and they are going to give you a certificate. Right? The certificate has to be printed. It's again a business rule kind of a thing to assure your amount of money is deposited there. That's certificate you are going to get. Apart from that, based on the amount and based on the period you are going to deposit, it can be in some banks it can be 1 month, in other banks it may be 3 months onward, in multiples of 3 months, right? And how it has to be updated after the completion of that period, right? If you look at the form to be filled in that banking, in that particular bank, you get to know many different business rules they have to implement within the bank. Most probably they have it already implemented, but the interest rates are changing time to time. Then those identified business rules has to be different from different age limits. For an example, senior citizens and juniors, teenagers, they are going to get certain type of accounts, and their interest rates are also different. Everything is modeled and implemented as a business rule in their banking system. Therefore, you can explain such points in your explanation for the question. Then we would briefly look at one another example. So when you identified a business rule, normally it will become a constraint at the database level. So you have to include it as a constraint. So if you take this example, each invoice should have a unique number to identify it. Therefore, you can come up with something like introducing a primary key. You can implement that business rule in the database. Okay. Once you implemented that business rule, you can never insert another invoice having the same number. I think it's clear to you. So in that case, if you look at the constraint, I think you are familiar with the term constraint. It defines the way that database engine automatically enforces the integrity of the database. So as we learned by now, constraints defines rules regarding the values allowed in the columns. And it is also a standard way of enforcing the integrity constraints within the database. And also you can specify a particular field as null, where you should not accept the null values. For an example, in banking system, you may have many not null fields. Can you just name a few? What are the fields you should not have blank or null values?
Primary keys.
Yeah, primary key is obvious. Apart from that, if you take other set of things, it's a key. To be a key, you should not have a null value. It's a definite thing. Other than that, other than the keys, what other values should not have now? Actually, you should not confuse with keys and the not null, right? It's a requirement of a key not to be null. It's a requirement, right? But there are many attributes which are not keys, but you should have some value, right? Can you name a few?
Customer NIC number, customer name.
Yeah. If you take customer name, then it's not anyway, it's not a unique value, right? It cannot be taken as a key because there can be many customers having the same name, but that field should not be null, right? Even though it's not a key, it should not be a null value, right? But your contact number or the telephone number, it's a unique one, but again, it can be a null value, right? Everybody is not having a telephone. If you take the whole population, right? Especially very elderly people does not maintain contact number, right? Therefore, even though your telephone number is like a unique value, so only one person can have one mobile phone number, but it is not considered as a key there. Therefore, you can have null values, right? It's a practical situation. Now you can look at this example. You can carefully go through and try to figure out what we discussed regarding the business rule. Right, I think everybody have gotten the idea. Now in practical approach, you should be able to convert a business rule into a database constraint. So you can, if you look at these two points I have mentioned here, two examples actually. Someone is running a business and he wants to identify each customer with a number, and this number cannot be duplicated. So how can you implement such a thing? It's very straightforward. That example is, this is similar to what I previously told. So you can come up with a primary key. Normally we do not use existing keys as primary keys. If it is really need, we use. Otherwise, the best way is to give our own employee ID. Right? We may have NIC number as well, but we store it in the database. For our internal purposes, we normally define using an internal identification number. Normally, many companies provide their own identity cards for internal purposes. In such a way, they can use their employee ID. If you take the second one, A and B company, HR department wants to computerize their employee details, and they have 3 departments. So you can come up with something like department ID, and you can attach your department ID and the employee ID, then where the employees can be directly identified together who are working in which department. Right. With that, I'm going to give you another case study. So you can just go through the slide. Sunil is running a small business. The description is given here, so you just go through the description. Now he can do the following changes. So with that, you can try to find the answers for the questions I have given at the end of this slide. Right, what are the things, what do you feel as the lacking part of this existing business rules? Then after, you can suggest how to implement and address the challenges he found in existing way of his doing their business. You can come up with your own answer. So I'd like to go to the next slide before we wind up. Normally, in general, we do not convert every incident into a business rule. You can classify the incidents normal, critical, or highly critical, and you can group them to create one rule to address many incidents. Right? For an example, you can come up with a fingerprint scanning machine where you can address all the attendance related matters, right? For an example, the people do not come on time, or people does not apply leave. There can be many reasons now, as I showed you in the leave system. There can be many reasons, so you come up with the inputs can be taken from the finger print scanning machine, and then you can implement the relevant business rules. It can cover all the attendance related matters in the organization. When you come up with business rules, you can first write in simple or discuss among the team. If it is in really industrial environment, you can normally you should have meetings and come up with the business rules, and you can discuss among the stakeholders to fine tune before you publish in the system. In summary, we were discussing about the business rules and creating how to translate business rules into constraint. And we were discussing about the practical situation. We also looked at the case studies, and we discussed and we learned about the creating business rules, right?